overlapping set occurs when you have people or items separated into groups, and then you have certain people or items that appear in more than one group. There are two ways generally that you can diagram or illustrate overlapping sets. The first way is with a Venn diagram. With a Venn diagram, each circle signifies a particular group. Where the circles overlap, that indicates times when you have people in or items in more than one group. So in this case, I have pink, light blue, and yellow groups, and you can see where they overlap. In the outer regions, that's where we put the number of people who are only in one group. In the dark blue and the green and the red regions, that's where you put the number of people who are in both of the circles. And in the black region in the middle, that's where you put the number of people or items that are in all three groups. Generally speaking, you'll use a Venn diagram when you have 3 or more groups. If you only have 2 groups, then we use what's called a double matrix, which is essentially a large addition grid. So if I had 2 groups of people who played piano and soccer, I would make the top part of my grid for the people who played piano, and the side would be about the people who played soccer. Along the top, I label my grid as piano yes and piano no, and when I add the people who play piano plus those who don't play, I get the total of everyone in the 2 groups I'm talking about. And then I do the same thing with soccer. The top row is the people who play soccer. The next row is the people who don't play soccer. And then when I add those together, I get the total of the groups. So in the top left box, where the piano yes and soccer yes intersect, that's where I put the number of people who play both. Where the soccer no's and the piano no's intersect, that's where I put the number of who play neither. And then in this box here, that's where I put the people who play soccer but not piano. And then in the total, that's everyone who plays soccer. Down here, I have the people who would play piano yes but don't play soccer. And then over here, I put the total of people who don't play soccer. And then on the bottom here, I put either the people who play piano or all the people who don't play piano. And then finally, in my bottom right-hand corner, I get the grand total of everyone in the group. In this problem, we have students who speak French, Spanish, or Japanese. We have 3 groups, so we're going to use the circular Venn diagram. And I'll label my Venn diagram with French, Spanish, and Japanese. The problem tells us that none of the students study all 3, so we can put a big 0 in the middle where all 3 circles overlap. The problem then tells us that 22 students speak French, but we're not exactly sure where to put that 22. It could be 22 students speak French only, or we could put some of those students in the part where we speak French and Spanish. So our only choice for now is to label each position in the overlapping set with variables. So I'll call these spots A, B, C, then D, E, and F. So if 22 students speak French, I can write the equation that A plus B plus C equals 22. And if 20 speak Spanish, I can write that B plus D plus E equals 20. And 15 study Japanese, so C plus E plus F equals 15. Now, the question tells us we have a total of 45 students, but when we add all of the students from our overlapping set, we actually get a number much larger. We have a total of 57. And if we look at our algebra, we can see why. The students in group B got counted twice. And so did the students in group E and the students in group C. So therein lies the problem with overlapping sets. Because people are in multiple groups, if you add up all of the people in all the groups, you get a number that's bigger than the actual number of individual people. So if we take our number of 57, the number of all of the people in all the groups, and subtract the real number of students, we can see that 12 students were counted twice. And in this case, that works out great because that is what the question is asking. The question is asking how many students study 2 languages. In other words, how many students were counted twice. So that number is 12. Now that we've identified the real problem with Venn diagrams, in that certain items or people in the group get counted multiple times, we can use that to find some really great shortcuts in Venn diagram problems. For example, in this problem here, they tell us we have 20 in basketball, 25 in soccer, and 12 in tennis. If we add those together, we get a total of 57 players. But then the problem tells us we have 6 students who are in both basketball and soccer, 5 who are in basketball and tennis, and 3 who are in soccer and tennis. In other words, those are the students who will get counted twice. So to find out how many students we have total, we have to subtract the students who got counted twice one time, because at the end, we only want students counted once. The problem tells us there were no students in all 3, but if there were some students in all 3, we would also have to subtract them from our total, but we would have to subtract them twice because we only wanted them counted once. In other words, our equation would look like this: the total of everyone in the groups minus the students who were counted twice, and then minus the students who were counted 3 times. In this case, it's 0, but I'm still going to subtract 0 so you could see how you would do it if there were students who were counted 3 times. And then that should give us our true number of total students. Or the total number of students in all the groups is really only 43. In this problem, we have a large group of 180 employees, and within this group of employees, we only have 2 subgroups. We have managers and those who have advanced degrees. So since we only have 2 subgroups we're looking at, we're going to use the double matrix. And I'm going to label my matrix as managers yes, managers no, advanced degrees yes, and advanced degrees no. Then on my edges, I have my totals. And then in the bottom right hand, I'm going to have the grand total. They tell me my grand total of employees is 180. And 35 are managers. That's going to go in my total of managers yes down at the bottom. And then 50 of the employees, the total of them, have advanced degrees. So that goes in my advanced degrees yes total. And then 125 of the employees are neither managers nor do they have advanced degrees, so that goes in my middle. And since this is simply an addition table, I can easily fill in the rest. So starting on the right-hand column, 50 plus something equals 180. So that means my total of advanced degrees no must be 130. And then adding across the right, I know something plus 125 equaled 130, so that something must have been 5. And then adding down, I know something plus 30 or something plus 5 equaled 35. So that would be 30 there and 20 here. And then I add those down to find 145. And that's it. And now we simply have to answer what the question is asking us for. They want to know how many are both managers and also have advanced degrees. That's going to be my top left box, my managers yes and my advanced degree yes, or 30. Let's try one more just for fun. In this case, we have a group of rooms that were either rented or not rented and either have air conditioning or not air conditioning. So that's how I'm going to label my grid. I have rented yes, rented no, and air conditioning yes, and air conditioning no. Now, if we look at the question, we've got some potentially ugly fractions to deal with. We're going to be dealing with 3/4 and 3/5 and 2/3, and that could get pretty messy. But if we look at the question is asking us for a percent of the rooms. We don't have to know the actual number of the rooms. Whenever a question is asking for a percent or a ratio, we can simply make numbers up or plug numbers in. And that'll save us from having to deal with a lot of fractions, which can be kind of a pain if we're talking about adding across the table. So when I look at the fractions we're dealing with, I notice the denominator has a 4, and then a 5, and then a 3. So we want to choose a number that's easily divisible by 4, 5, and 3. So we could say there were a total of 60 rooms to begin with. And then it rented 3/4. And 3/4 of 60 is 45. So 45 were rented, 15 were not. Then it says 3/5 of its rooms were air conditioned. So 3/5 of 60, that's 36. So 36 air conditioned yes, which means 24 air conditioned no. And then they say they rented 2/3 of the air conditioned rooms. So that means in the rented yes and air conditioned yes goes 2/3 of 36 or 24. Which means the air conditioned yes but not rented must be 12. And then that means the rooms that were neither rented nor had air conditioning must be 3 because we know the total of not rented is 15. And then 21 goes in our last box. Now they want to know what percent of the rooms that were not rented had air conditioning. Well, we know there were 15 not rented and 12 had air conditioning. So our answer is just going to be 12 out of 15. And then we could reduce that down to 4/5. So 4/5 or 80% of the rooms that were not rented had air conditioning.